Okay, next is about rate law. Okay, rate law ataupun rate equation is actually an equation yang akan relatekan the rate of reaction to the rate constant, and concentration of the reactants will be raised to some powers. Okay, kalau rate law, dia sangat berkait rapat dengan order of reaction. Okay, so kalau soalan tanya order of reaction, you terus kaitkan dengan rate law equation. You jangan kaitkan dengan, okay, you jangan kaitkan dengan differential rate law equation. Okay, because differential rate law equation is a different thing. Bila soalan tanya pasal order of reaction, bila you nak build the rate equation, you guna rate law equation. Okay, for example, kalau you ada reaction, chemical reaction di mana reactant kamu ialah A plus B, okay, and then product kamu ialah C plus D. I know that bila kita buat differential rate law equation just now, kita ambil kisah dia punya stoichiometric coefficient, kita ambil kisah produk bila kita nak write dia punya rate law equation. But then when it comes to the rate law yang sebenarnya yang mengaitkan order of reaction ni, bukannya differential. Kalau soalan tak mention differential, soalan mention pasal rate law equation, yang the real rate law equation. Actually, we don't care about the product, we don't care about the stoichiometric coefficient at all. Okay, so when it comes to the rate law equation atau yang menyebabkan untuk kamu mencari order of reaction, so when you want to write the, bila you nak tulis the rate law equation, it's gonna be rate, rate ni wajib lah you letak rate, mukadimah dia, rate is equals to, since that rate law equation you kena relatekan apa tu, rate constant kan. So K ni adalah rate constant, so rate is equals to K kalikan dengan concentration of the reactants raised to some powers. So in this case, your reactant, okay, in this case your reactant ialah A dan juga B. Okay, so that's why when you want to write the rate law equation, it's going to be rate is equals to rate constant kalikan dengan concentration of A, sebab reactant you A kan, raised to some power. Okay, raised to the power of X. Okay, kalikan dengan concentration of B raised to the some power Y. Okay, di mana K ialah rate constant, X ialah order of reaction with respect to A, Y pula ialah order of reaction with respect to B. Okay, and then kalau you nak tahu overall order of reaction, is going to be X plus Y. Okay, for example lah, Miss nak bagi example sekejap lah. Kalau let's say you ada, okay lah, kalau let's say you ada reactant A, and then you akan dapat produk kan. So bila you nak write the rate law equation for this chemical reaction, is gonna be rate equals to K kalikan dengan concentration of A to the power of X. Okay, and then if let's say you ada the next punya chemical reaction pula, which A, you ada reactant A plus B plus C, and then you akan dapat produk. Okay, so bila you nak write the rate law equation for this chemical reaction, it's gonna be rate is equals to K kalikan dengan concentration. Apa concentration? Ada 3 kan? Concentration of reactant, ada 3 jenis different reactants kat sini, so you tulis all of the reactants here. So reactant yang pertama A to the power of X, reactant yang kedua ialah B, you buatlah to the power of Y, and then reactant yang ketiga ialah C, you buatlah to the power of Z. Okay, so kiranya kalau let's say for this chemical reaction, if you want to know the overall order of reaction, X pluskan dengan Y pluskan dengan Z. Okay, sebagai contoh, kalau let's say X ni nilai dia 1, Y nilai dia 2, Z dia nilai dia 3. That means the overall order of reaction for this chemical reaction is gonna be berapa? So overall dia overall order of reaction dia is going to be 1 plus 2 plus 3, which is equals to 6 order. Tapi 6 order ni kita tak study lah. Tapi Miss nak tunjuk contoh je. Okay, contohnya kalau kat sini pula A to the power of X kan. So contohnya kalau you kira-kira order of reaction ni is something that you need to find tau, order of reaction ni. Nanti Miss bagi tahu lah macam mana kamu boleh cari order of reaction ni. Okay. Lepas tu kalau contohnya lah X ni kan, Miss kira-kira Miss dapat 2. Okay, Miss dapat 2. So, therefore, I can say that the overall order of reaction for this chemical equation is going to be second order. Second order. Okay. So sebagai contohnya, kalau let's say for this type of chemical reaction di mana reactant I ada A dan juga B kan. So if let's say I kira-kira order of reaction dia, I dapat this one 1, this one pun 1. So kalau let's say overall order of reaction for this chemical reaction, X campurkan dengan Y, 1 campur 1 is equals to 2. So overall order of reaction dia ialah second order. Okay. So order of reaction ni is something that you need to find. Okay. Need to find. Alright. So rate constant, it relates to the rate equation to the concentration of reactants. Bermaksud, okay, the larger the value of the rate constant, the faster the reaction proceeds. Alright. Kan tadi kan Miss cakap order of reaction ni is something that you kena cari kan. So sebagai contoh lah, kalau you ada experimental data and you need to find the order of reaction, how can you find it? You can find it from the method of initial rate method. Initial rate method ni lah one of the methods untuk you cari order of reaction melalui experimental data. Okay. Kalau initial rate method, dia berkait rapat dengan rate law equation. Okay. Contohnya lah, kalau you ada chemical reaction di mana you nak menghasilkan nitrogen dioxide, so the reactants are oxygen and nitrogen oxide. Okay. And then, from the following data collected at certain temperature, calculate the order with respect to each reactants. Okay. So kalau you ada experimental data macam ni, and then soalan suruh kamu cari order of reaction. Okay, order of reaction, order with respect to each reactants pula tu. So kat sini you kena cepat-cepat fikir, you kena cepat-cepat buat rate law equation. Okay. So nak tulis rate law equation, you kena tahu rate is equals to, kalau generally lah before this we know that kalau rate you ada dua jenis reactant, it's gonna be rate is equals to K kalikan dengan concentration of reactant A to the power of X kalikan dengan concentration of B to the power of Y kan. Tapi in this case kita punya reactant bukanlah A dan B. Reaktan kita ialah oksigen dan juga nitrogen oxide. Okay, so these two ialah kita punya reaktan. And what do I tell you about rate law equation? Kalau rate law equation tak sama dengan, okay, rate law equation tak akan sama, can never be the same as differential rate law equation. Okay, so kalau rate law equation, bila you nak tulis dia punya rate law tu punya equation, you will not care about dia punya stoichiometric coefficient and you will not care about dia punya product. Okay, so kalau rate law equation, you will not care about these two. Okay, bila you nak tulis dia punya rate law equation, so bila you nak tulis rate law equation dia, nanti you masukkan je lah A ni, you substitutekan dengan oksigen, B ni you substitutekan dengan NO, Nombor 2 ni tak akan ada jadi makna dah. So, inilah dia solution bila you nak cari the order of reaction with respect to reactants by using the experimental data. Okay. So the first thing first that you need to do ialah you kena write down the rate law equation for the chemical reaction yang dah diberi. So kita tahu reactant yang diberi ialah oksigen dan nitrogen oxide. So when you want to write down the rate law equation, it's going to be rate equals to rate constant kalikan dengan concentration of oxygen, reactant oxygen to the power of X, and concentration of nitrogen oxide to the power of Y. Sebab X represents, because before this we know that X represents the order of reaction with respect to oxygen. Okay, while Y pula represents order of reaction with respect to nitrogen oxide. Okay, so bila you dah write down the rate law equation in general for the above reaction from the previous punya slide, okay, next what you need to do ialah you kena compare dua eksperimen di mana one of the reactant tu punya concentration tu kena berubah, while the other reactant tu punya concentration kena remains constant. Okay, for example, kita ada 3 jenis eksperimen kat sini. Eksperimen 1, 2, 3. And then kita ada concentration of oxygen respectively, concentration of nitrogen oxide respectively, and also the initial rate dalam unit molar per second for eksperimen 1, 2 and 3. So kalau ikutkan second step ni, I need to compare dua jenis eksperimen yang di mana one of the reactant tu concentration dia kena berubah, manakala one of the reactant tu concentration dia kena remain constant. If I look at this table, I can see that concentration of oxygen for eksperimen 1 dan 2 sama, constant. Manakala concentration of nitrogen oxide untuk eksperimen 1 dengan 2 pula berubah. Okay. So, sekarang ni, apa yang I boleh buat ialah I bolehlah comparekan eksperimen 1 dengan 2. So, now I can write the rate law equation untuk eksperimen 1. Untuk eksperimen 1, if I want to write the rate law equation, is going to be rate untuk eksperimen 1 equals to K, rate constant untuk eksperimen 1. Okay, concentration of oxygen to the power of X untuk eksperimen yang pertama kalikan dengan concentration of nitrogen oxide to the power of Y untuk eksperimen yang pertama. Okay, while eksperimen yang kedua punya rate law equation pula is equals to rate untuk eksperimen yang kedua, rate equals to K. K2 tu sebabkan rate constant untuk eksperimen kedua, and then concentration of oxygen to the power of X untuk eksperimen yang kedua kalikan dengan concentration of nitrogen oxide to the power of Y untuk eksperimen yang kedua. Okay, and after that, okay, yang ni initial rate ni, this one represents rate punya information. Okay, so you dapat information rate ni daripada initial rate. Okay, so you get this value daripada initial rate value on the table. Okay, on this table. So you masukkanlah rate untuk eksperimen yang pertama ialah 2.2 times 10 to the power of negative 4. Rate untuk eksperimen yang kedua ialah 1.1 times 10 to the power of negative 4. K ialah rate constant. K is something yang tak diberi. Okay, it will not be given. Okay, while concentration of oxygen untuk eksperimen yang pertama ialah 0.08 to the power of X. X ni you jangan buat apa-apa because X ni lah order of reaction with respect to oxygen. And then concentration of nitrogen oxide ialah 0.034 to the power of Y. And then untuk eksperimen kedua, concentration of oxygen still remain constant. Concentration of nitrogen oxide berubah, which is 0.017 right now. Okay, so sekarang ni, you cari persamaan yang you boleh cancel. Okay, in this case, K is something that you can cancel. Because K ni dah dibagi kan. So dia sama je actually untuk eksperimen 1 dengan 2. So it can be cancelled out. And another thing that can be cancelled out ialah 0.08 to the power of X. Makanya tinggallah yang distinct rate 1 dengan rate eksperimen 2 yang you boleh bahagikan. Bila you bahagikan, you akan dapat 2. And then bila you bahagikan 0.034 divide by 0.017 and you will get 2 but to the power of Y. And now, how can you find Y? Sebab 2 to the power of 1 equals to 2 to the power of Y. You can cancel out digit 2 ni, and now you will get Y equals to 1. Okay, what do we talk about Y? Y ni ialah order of fraction with respect to NO, kan? Y is the order of fraction with respect to reactant nitrogen oxide. Therefore, the reaction is first order with respect to NO. So, ni penting tau untuk kamu tulis ni. These two things, okay? Kamu jangan dah dapat jawapan Y equals to 1 and then you tinggalkan je kat situ. Tak boleh. You kena tulis dua benda ni, okay? Okay, next ialah I dah dapat kan order of fraction with respect to NO. Untuk dapatkan order of fraction with respect to oxygen, I need to find experiment di mana value of concentration of NO2 constant. So, I boleh dapat kat sini eksperimen 2 dengan 3 menunjukkan yang value of concentration of nitrogen oxide constant while concentration of oxygen berubah, varies. So, I nak compare lah eksperimen 3 to 2. Okay, so now I write down the ratio of experiment 3 to 2, okay, di mana this is the rate law equation untuk eksperimen yang ketiga and this is the rate law equation untuk eksperimen yang kedua, and after that I masukkan sahaja value masing-masing and I boleh cancelkan the K and I can also cancelkan concentration yang constant untuk NO, which is 0.017 to the power of Y. Maka yang tinggal ialah ratio of rate eksperimen 3 bahagi 2 and also the ratio of concentration of oxygen 0.16 divided by 0.08. Now I will get that 2 is equals to 2 to the power of X, and to find the X, so I know that 2 to the power of 1 is equals to 2 to the power of X, so I can cancel out digit 2, so now X equals to 1. And we have discussed just now, X is the order of fraction with respect to oxygen, right? Therefore, the reaction is first order with respect to oxygen, okay? Alright, and I want to give you some bonus here, okay? Contohnya lah, kalau soalan suruh kamu cari rate constant. Okay, so to find the rate constant, okay, so once you have found the rate of reaction, once you have found the order of reaction with respect to each of the reactants, okay, so senang untuk kamu find the rate constant. Rate constant tu apa? Rate constant ialah K. So to find the value of K, okay, you substitute saja ya. Substitute any of the experiment value to the rate law equation. Sekarang ni rate law equation dia dah lain dah kan? Rate law equation dia once dia dah jumpa dah jumpa order of fraction with respect to each of the reactants. So now dia punya rate law equation dia akan jadi rate is equals to K concentration of oxygen to the power of 1 concentration of NO to the power of 1. Okay, so sekarang ni kalau you nak cari nilai K, you substitute je mana-mana eksperimen kat sini into this rate law equation yang you dah jumpa dia punya order of reaction. Okay, so nanti you akan dapatlah K kamu tu apa. And then to find the unit of K, you need to be able to substitute the unit of rate and unit of concentration. Okay, so contohnya lah, when you want to find this K, you tahu unit rate ni ialah molar per second. Unit concentration molar, kan? Okay, so kat sini you want to find the K here. So K punya unit is gonna be equals to unit rate. Okay, unit rate ialah molar per second bahagikan dengan unit concentration of oxygen dan juga NO, which is M kalikan dengan M. Okay, so you tahulah M kali dengan M ialah molar squared. And then to find the unit of rate constant ni, M ni akan cancel out dengan one of this. So now you will get as -1 M. Okay, and it will be equals to M -1 S -1. So the unit of rate constant yang you cari nanti is gonna be M -1 S -1. Okay. Alright, and then another thing, if let's say soalan tanya pasal overall order of reaction, if let's say the question asks you about the overall order of reaction, so kalau overall order of reaction, you tahu tadi you punya rate law equation, rate equals to K, oxygen to the power of 1, nitrogen oxide to the power of 1. Kalau you nak tahu order of reaction, before this, we know that kalau nak tahu overall order of reaction, yang power tu kan X pluskan dengan Y. Since you dah tahu X1, Y1, therefore overall order of reaction ialah second order of reaction. Okay? Okay guys, so order of reactions ni apa? By definition, order of reactions ni dia adalah numerical value yang menunjukkan concentration tu punya perubahan bila sesuatu spesies tu berubah in a chemical reactions. Okay, consider if let's say you ada chemical reaction di mana reactant kamu A. Okay, and then kamu akan dapat produk. So kalau you nak cari order of reaction, you kena buat rate law equation. Okay, penting untuk you buat tahu macam mana nak buat rate law equation, di mana rate is equals to, you kena kaitkan dengan rate constant and also the concentration of reactant raised to the sum power. Okay, di mana power tersebut merujuk kepada order of reaction with respect to the reactant. In this case, rate is equals to rate constant kalikan dengan concentration of reactant A to the power of X, di mana X ni ialah order of reaction with respect to A. This is something that you need to recall lah from previously, kan? Okay, so kalau let's say if it's a zero order reaction, mestilah X ni kena equals to 0. So bila X equals to 0, rate will be equals to K kalikan dengan concentration of A to the power of 0. And then you need to know anything kalikan dengan to the power of 0, it's gonna be 1, kan? So it's like K kalikan dengan 1. But you know that this reaction is actually zero order with respect to A. Therefore, kalau untuk zero order reaction, okay, for zero order reaction, rate will be equals to K sahaja. Okay, rate dia tak akan depends pada concentration of reactant langsung. Okay, next, kalau for first order reaction, okay, kalau first order reaction, if let's say you ada chemical reaction di mana reactant kamu A And then kamu punya rate law equation you, rate is equals to K kalikan dengan concentration of A to the power of X, di mana X ni ialah order of fraction with respect to A. So kalau first order of fraction, mestilah X dia equals to 1. So bila X equals to 1, rate will be equals to rate constant kalikan dengan concentration of reactant A to the power of 1. So this fraction is actually a first order with respect to A. So therefore, kalau untuk first order fraction, dia punya rate will be equals to K kalikan dengan concentration of A to the power of 1. Okay, kerana first order fraction, dia depends on the concentration of reactant but with the power of 1. Okay. Kalau second order reaction pula, mestilah X kamu tu, nilai X ni must be equals to 2 sebab X ni ialah order of fraction with respect to A kan. So therefore, kalau rate untuk second order fraction, rate dia will be equals to K kalikan dengan concentration of A to the power of 2. And this fraction is actually a second order with respect to A. Okay, actually in matriculation, you hanya akan belajar deeply about zero order fraction, first order fraction and second order fraction. Okay. Alright, tadi macam Miss dah buat contoh tadi kan, kalau consider you ada chemical reaction di mana reactant kamu ada satu saja, which is reactant kamu A. Alright, so if you, kita dah buatkan tadi kan rate law equation for zero first dengan second order reaction. So kalau rate law equation untuk zero order, rate dia will be equals to K. And you will know that the reaction is actually tak depend pada concentration of reactant langsung, because tiada langsung reactant kat sini, because to the power of 0 kan. Kalau first order of reaction, dia punya rate law equation dia ialah rate equals to K kalikan dengan concentration of A to the power of 1. Bermaksud reaction ni, rate dia tu depends pada concentration of reactant raised to the power of 1. Okay. Manakala second order of reaction pula, dia punya rate law equation dia ialah rate equals to K kalikan dengan concentration of A to the power of 2. Okay, bermaksud reaction ni, rate dia depends kepada reactant, concentration of reactant raised to the power of 2. Ataupun, okay, ataupun if let's say you ada dua jenis reactant. If let's say you ada dua jenis reactant di mana chemical reaction you A pluskan dengan B dapat produk kan. Mestilah dia punya rate law equation dia ialah rate is equals to K concentration of A to the power of X kalikan concentration of B to the power of Y. Macam tadi contoh yang Miss tunjukkan oksigen dengan nitrogen oxide. So kalau let's say X dengan Y ni both raised to the power of 1. Okay. So X ni power dia 1, B ni power dia 1. Therefore, dia punya overall order of reaction mestilah second order kan. Sebab itulah dia kata or kalau let's say you ada dua different reactants, each raised to the first power pun itu adalah second order reaction. Okay, so order of reactions ni is something yang you kena cari, okay, and it can be determined by using several methods, okay, such as initial rate method. Ingat lagi tak initial rate method yang Miss dah terangkan before this? Initial rate method ni, kalau kamu tak ingat, initial rate method ni is a method yang bila kita compare dua jenis eksperimen, okay, two types of experiments, okay, by using experimental data. You ingat tak yang kita kena compare dua jenis eksperimen yang di mana one of the eksperimen tu dia punya concentration of reactant tu kena constant while the others tu kena berbeza. Okay, itulah initial rate method. Yang kedua pula ialah melalui linear graph method based on integrated rate law equation. This one ialah kita akan study nanti. And next ialah based on half-life graph of concentration against time. Okay, yang ni pun kita akan study nanti. And lastly is by observing the unit of the rate constant that is given. Okay, I want you to look at this table. This table is a very complete table untuk zero order, first order and second order. Tapi Miss akan hanya highlightkan the one yang important je lah. Okay, so the one yang important is rate law equation. Rate law equation untuk zero, first and second order. Yang ni kita dah Miss dah tunjuk tadi, dah go through macam mana kamu boleh dapat this kind of equation. And next ialah integrated rate law equation. Okay. Integrated rate law equation ni kamu janganlah pula tanya Miss macam mana ni. This is something yang you kena hafal. Alright. Macam ni, kenapa dia ada dua jenis? Because kalau dalam bentuk natural log, if it's in a ratio, kalau you nak jadikan dia dalam satu baris kan, it's gonna be natural log concentration of if let's say reactant kamu A, so it's gonna be concentration of reactant initial minus dengan concentration of reactant final. Tapi nanti Miss akan terangkan further lah about this. And next is half-life equation. Okay, so these are half-life equation specifically for zero, first and second order respectively. And next ialah unit of rate constant. Okay, ni pun penting juga sebab kenapa sometimes dalam soalan dia tak bagi tahu what is the order of reaction, tapi dia bagi tahu rate constant. K tu unit dia berapa. Kenapa kat sini Miss tulis atau ni? Okay, because some in rate of reaction saja, time tu dia tak specific. It can be hours, it can be minute. Okay, so tak specific unit time tu in second. Okay, so that's why Miss buat sama ada molar. Ni bukan meter tau, ni molar. Sama ada molar per second atau molar per time. Okay, macam ni pula first order reaction sama ada per second atau per time. This is a second order reaction di mana it can be either per molar per second ataupun per molar per time, per unit time. Okay, tak kisahlah unit time kamu apa. Okay, and the next one is this graph. Okay, this linear graph penting sebab this linear graph dia berkait dengan integrated rate law equation punya graph. Okay, so this graph related to this. Alright, so these are the graph for zero order, first order and second order respectively. And last one, this graph is important too. Okay, this graph is important juga because this graph represent graph yang related to half-life. Okay, alright, and okay, this graph dua ni macam tak penting sangat lah. Macam graph ni I think you ada dah guna time experiment satu kamu. Okay, ni pun macam tak penting sangat. Okay, yang penting ni 1, 2, 3, 4, 5, 6 items yang penting for zero, first and second order.